problem. Find the Z transformation of n plus 1 into n plus 2, right? So take f of n 1 into n plus 2. So removing the brackets, so n into n square, n into 2n 2n, 1 into n plus 1 into 2 2. So you will get n square plus 3n, 2n plus n 3n plus 2, right? We know the formulas z of n square, which is equal to z square plus z by z minus 1 the whole cube, z of n, which is equal to z by z minus 1 whole square, and z of k, which is equal to k z by z minus 1. Now we will take z transformation of n plus 1 into n plus 2. So n plus 1 into n plus 2 is nothing but n square plus 3n plus 2. So replacing, we will get z of n square plus 3n plus 2. So taking z transformation of each terms, so which is equal to z of n square plus z of 3n plus z of 2. So z of n square, we know the formula, right? So replacing z square by plus z by z minus 1 the whole cube. Now we know z of n, which is equal to z by z minus 1 the whole square. Here you are having z of 3n. Take the 3 outside the z transformation. So z of 3 into z of n. So 3 into z of n is nothing but z by z minus 1 square. So you will get 3z by z minus 1 the whole square. Last term, so you are applying z of k. Z of k, which is equal to 2. So you will get 2z by z minus 1. Right? Now we are taking the LCM. So z minus 1 whole cube is the LCM. So first term in the numerator is z square plus z. So denominator is z minus 1 the whole cube. So we are writing the same thing, z square plus z. Second term, so the denominator is z minus 1 whole square, but the LCM is z minus 1 whole cube. So we are multiplying. So what is the balance remaining? You are having z minus 1, right? Z minus 1 into z minus 2, z minus 1 whole cube. So we are multiplying z minus 1 to the numerator. So 3z into z minus 1 plus the last term. So in the denominator you are having z minus 1, but the LCM is z minus 1 the whole cube. So difference is z minus 1 whole square, right? Z minus 1 whole square into z minus 1, you will get z minus 1 whole cube. So multiplying the numerator with z minus 1 the whole square. So you will get 2z into z minus 1 whole square. So expanding the numerator. So z square plus z plus 3z square minus 3z, multiplying with 3z, right? With z minus 1. Then plus second term 2z into z square minus 2z plus 1. Z minus 1 the z minus 1 the whole square, right? Using a minus b whole square formula. So that is z square plus z plus 3z square minus 3z plus 2z cube, multiplying with 2z and z square. So 2z cube minus 2z into 2z minus 4z square, 2z into plus 1 2z. So z of n plus 1 into n plus 2, which is equal to, so in the numerator see z cube term, so 2z cube, then z square term. So you are having 3 plus 1 4z square plus 4z square minus 4z square get cancelled. Then z term, so minus 3z and 2 plus 1 3z. So plus 3z minus 3z get cancelled. So you will get 2z cube by z minus 1 the whole cube. Next problem, z transformation of n into n minus 1 into n minus 2. Take f of n, which is equal to n into n minus 1 into n minus 2. So multiplying n into n square minus 3n plus 2, right? Again multiplying with n cube minus 3n square plus 2n. So z of f of n, which is equal to z of n cube minus 3n square plus 2n. So taking z individually, so you will get z of n cube minus 3, take 3 outside, so minus 3z n square, take 2 outside the z transformation plus 2 into z power n. We know the formulas, z of n square, which is equal to z square plus z by z minus 1 whole cube. Z of n, which is equal to z by z minus 1 square. and z of n cube, which is equal to z cube plus 4z square plus z by z minus 1 power 4. So applying this formula, you will get z of n into n minus 1 into n minus 2 is equal to z cube plus 4z square, right? Z of n cube formula plus z by z minus 1 power 4. Then z of n square formula minus 3 into z square plus z by z minus 1 whole cube. Then z of n formula plus 2 into z by z minus 1 square. So LCM z minus 1 power 4. So in the numerator first term, so denominator is z minus 1 power 4. So write as it is z cube plus 4z square plus z. The second term, you are having the z minus 1 whole cube in the denominator. So remaining you are having z minus 1, right? For z minus 1 power 4, which is equal to z minus 1 into z minus 1 cube. So multiplying the numerator with z minus 1. So minus 3z square plus z into z minus 1. Then last term, the denominator you are having z minus 1 square. So remaining you are having z minus 1 square. Because z minus 1 square into z minus 1 square, you will get z minus 1 power 4. So multiplying the numerator with z minus 1 square. So plus 2z into z minus 1 square. So the numerator z cube plus 4z square plus z minus 3 into multiplying that term z square into z cube, right? Z into z square. So z square into minus 1 minus z square. Z into minus 1 minus z. Second term a minus b whole square formula 2z into z square minus 2z plus 1. So we will get in the numerator z cube plus 4z square plus z minus 3z cube minus 3z square plus 3z square plus 3z plus 2z cube minus 4z square plus 2z. Now grouping all those things, z cube term first. So minus 3z cube plus 2z cube plus z cube. So 3z cube minus 3z cube get cancelled. Next z square term, 4z square minus 4z square get cancelled. Then 3z square, then minus 3z square get cancelled. Then z term plus z plus 4z. So plus 3z, right? Z plus 3z, 4z, then plus 2z, 6z. So numerator 6z by z minus 1 whole power 4, right? Thanks. We'll see you in the next video.